Alright, so today we will continue with exercise 8.4. Alright, so two brothers sit for a geography examination and their independent probabilities. So what does independent tell you? What does independent tell you? The intersection is equal to the multiplication. This is the independent rule. This rule. The intersection is equal to the multiplication. So when you have anything that is independent, always have this in your mind. Alright? Okay, so I've done the working for you. So I'll just quickly go through and then I will leave you to pause and play and do it on your own, okay? So what's the probability? They both pass, you multiply both. They both fail, you find the probability of the first one failing, which is 1 minus passing, 0.1. 1 minus 0.8, 0.2, you multiply, they both fail. Find the probability of winning 3 times in a row with each spinner, meaning I use this spinner, I win all 3 rounds. So what's the probability of winning all 3 rounds? First round win 1 over 2 times 1 over 2 times 1 over 2, 1 over 8. For this spinner, win all 3 rounds, 1 over 4 times 1 over 4 times 1 over 4. Why? Because it's 1/4 of the circle. Okay, same goes to this. You're going to win all 3 rounds, 3 over 4 times 3 over 4 times 3 over 4. The spinner is spun twice, determine the probability of obtaining 2, then 3. So what's the probability of obtaining 2? 1 over 8. What's the probability of obtaining 3? 1 over 4. You multiply, you get 1 over 32. What's the probability of getting a 1? Then a 4. So the probability of getting a 1 is 1 over 8. The probability of getting a 4 is 1 over 2. You multiply. What's the probability of getting a 3? Then a 3. 1 over 4 times 1 over 4. What's the probability of getting no 3's? So I find the probability of getting a 3 first. Okay, all the probability of getting a 3 I find. I add up, I get 7 over 16. That means you find what's the probability of getting a 1 on a 3. So 1 is 1 over 8, 3 is 1 over 4. You multiply, you find the probability. So you find 1 by 1. So it'll be like 1 over 32, 1 over 32, 2 and 3 will be 1 out of 32, 3 and 2 will be 1 out of 32, like that. You find 1 by 1, then you add up, and 1 minus the probability of not getting, for not getting a 3 is 1 minus probability of getting a 3, you'll get 9 over 16. Or you can straight away find the probability of not getting 3. That means 1, 2, 2, 1, 1, 4, 4, 1, yeah, also can, doesn't matter. Okay? A coin is tossed 6 times, find the probability of getting all 3 times hit, so 1 over 2 to the power of 6. So same goes to the rest, it will be to the power of 6 because the probability of getting a tail and a head is the same, right? So are you more likely to get this or this? It's equally likely. Alright? The probability a man is retiring from his job dies within 5 years is this. Fred and his brother retired today. What's the probability they will both be dead? So 0.15 times 0.15. Fred will be alive. That means 1 alive, 1 dead. Just multiply. They both will be alive. 0.85 times 0.85, that's your answer. At least 1 will be alive. So whenever they ask you at least 1 will be alive, right, you just 1 minus both don't have. It's the fastest way to do it. So 1 minus both dead. So 1 minus both dead, 1 minus this, you get this. So what's the assumption that you use to arrive to your answer? They are independent. Their deaths are independent. That is why you can take the intersection. To find the intersection, you just multiply. A regular dice is thrown 3 times. Determine the probability of getting 3, 6. So 1 over 6 times 1 over 6 times 1 over 6. What's the probability of getting no 6? I want you to do it on your own. The way I did this, similar. Try it on your own. The answer is 125 over 216. You can get it. It'll be a bit of a tedious process, but you can get it. Okay? No 6's. That means no 6 in your answer. Alright? 3 spies work to crack an enemy code. The independent probabilities of cracking it is this. That means the probability that at least one of them, I already told you, when they ask you at least one of them cracks, you just take 1 minus no one cracks the code. That's the fastest way. If not, you have to find 1 by 1. 1 minus no one cracks the code. So 1 minus 0.4 times 0.3 times 0.2, it will be 0.976. No one cracks the code means what? 0.4, 0.3, 0.2, you just multiply. Okay? 1 minus this, 1 minus this, 1 minus, because probability of cracking is 0.6, not cracking 0.4. Okay? You get 0.976. On all three throws gets it in. So 0.9 to the power of 3, you get this. None of the throws it goes in, 0.1 to the power of 3, you get this. On the last row, but not on the first two. So first two not in, last row in, just multiply, you get the answer. X and Y are independent events. So if it's independent, what do you know? X intersection Y is 0.8 times 0.5, 0.4. You want to find union? I told you before when we did chapter 6, if you want to find union, is 1 minus the outside. If you 1 minus the outside, you will get the union, which is 0.9. Okay, 1 minus 0.2 times 0.5, you get 0.9. 1 minus the outside. 3% fail the pressure test, 2 are selected at random. So they both fail the test, 0.03, which is 3% times 3%, you get this. First fails, but the second doesn't. First passes, but the second doesn't. Same like this. All right. Only one cylinder passed the test. So only one cylinder passed the test is these two options. Okay. Is that two options? So you add up both the answers. That is it. Only one cylinder pass means one fail, one pass, one fail, one pass. Understand? Customers in a supermarket have a choice of 3 sizes when buying a particular brand of soap. They have regular, large, jumbo. These are sold in ratios of 2, 3 and 5. Find the probability that in the next 2 buyers for the soap powder both buy regular sizes. So both buy regular sizes. How to find regular first of all? Regular is 2 out of 10. Total is 10 one. So 2 out of 10 times 2 out of 10, 0.04. Both buy large sizes. 3 out of 10 times 3 out of 10, 0.09. Both buy jumbo. 5 out of 10 times 5 out of 10, which is 0.25. Okay. Both buy different sizes. So when you both buy different sizes, 1 minus all these 3 you add up, which is 0.62. A and P are random events. Determine whether A and B are independent. How to determine independent? The intersection is equal to A times B, right? So first one, A times B is 0.35. Yes, so this is yes. Second one, 0.5 times 0.7 is 0.35. But the intersection is 0.3. So it's not independent. So this one is a big no. Here, 0.5. Okay, you want B, right? So B is 0.4, correct? B prime is 0.6, probability of B is 0.4. So 0.5 times 0.4, you will give you 0.2. So this is also no. So probability of A will be 0.3, probability of B will be 0.6. But here is A prime intersection B prime, so you just multiply these two. 0.7 times 0.4 is 0.28. So yes, it is independent. That is how you prove. Understand? A property that it will rain. So pause as you go so you can read the question first, okay? Rain in both Perth and Singapore. So 0.6 times 0.7, 0.42. Rain in neither city. So never rain here, 0.4, never rain here, 0.3. You just multiply. Rain in just one of the cities. So you 1 minus rain in both. 1 and minus of the neither rains. So you just 1 minus these two, you will get the answer. Okay, now we will do the first 10 questions of exercise 8.5. All right, so I have all the working for you already here. So this is for the first question. Okay, the first question, to make up a team of 3 students, you're going to choose from here. So determine the probability that it will be Jack. So how do you find that probability? What's the probability it will be Jack? 1 out of 3, isn't it? Okay, so I've actually have it here already. I will share this slide as well with you. So just try to refer and see what's going on here. Okay, the probability that it is Mike. So how to find the probability that it is Mike? So Mike is here, right? So if you want to find the probability that it is Mike, you need to take, it could have been Jack, then Mike, it could have been, so this is how you do it. So you try it first. So the probability that is Mike, it will be 1 out of 2. It is half, right? Because out of 2 people that it would be Mike is half, isn't it? Okay. So refer back to this diagram and try. So pause as you go along. Okay, same goes to number 2. A bag contains 2 red, 1 blue and 1 green marble. The first marble is being replaced before the second. So it is independent. All right. So this would be the diagram for you. Okay, I have not put the probabilities here because I want you to try it on your own. Okay, I want you to try it. The probabilities will be the same because it's replaced, isn't it? Okay, so try it on your own first. They will have this as well. So follow conditional probability rule. Two rates given the first is rate. So you have to find, that means the bottom, all the first is rate, you have to add up all the probabilities. Where all of it, the first is rate. Okay? You need to basically, okay, if I were you, write down all the probabilities, write down all the outcomes, and then calculate the probabilities and put here. So the first is rate. So you need to take the probabilities, the first is rate, you add up all, that will be the bottom. Okay, that's how you do the conditional probability. Okay, so this would be the working. Pause and play as you go along. This is for question 3. This is question 3 for you in the manual. This is for question 3. Do it on your own. Put down the probabilities and try. If you still cannot, then you reach out to me. I will write out the working. But try first, okay? Actually, it's not that difficult. It's just that it's a lot of working. You got to put down all the probabilities, write it down. That's it. All right. Okay, this is for number 4. This is the drawing out for you. Okay, basically that's number 4. That's the answers. Okay, so you try and get it done. Number 5. This is the working for number 5. All right, this is the working. So 40, 40, not 40, not 40, 40, not 40. So you try first. And then this is number 6. The fair dice is roll 1. So what's the probability of getting a 5? 1 out of 6. So I've already wrote down the sample space for you. You find out accordingly. Conditional probability is similar to what we did before. So you try first, okay? Then you have question 7, which I have put down here. Basically, that's the working for you. That's the diagram. Let me see if I can bring this a little lower. Okay, yes, that's the lowest I can do, okay? Then question 8, again here, sample space is already there. That's the answers. All right, question 8 is the die again, so it's very much similar. Question 9, I have drawn out the tree diagram for you here. Let's see if I can bring this a little lower. Okay, that's the tree diagram for you. Question 10 is a two-way table. So try to manage it on your own first. Pause and play as you go along. All right, pause and play and try it out. Okay. All right, so we will stop at question 10. Please submit your work. Any questions, just reach out.